In this video, we're going to take a look at the electrochemistry questions from the KZN September 2025 paper. Question 8. An electrochemical cell is set up under standard conditions. A standard hydrogen electrode is connected to metal X in a solution of its ions. The following observations were made. The pH of the HCl decreases. That's important. Then they tell us the initial EMF of the cell is 0.34. Question 8.1. Which electrode, X or PT, is the anode of the cell? There's a few ways we could do this. Let's take a look at the pH method. So if we examine this first point, they tell us that the pH is decreasing. In other words, the solution is becoming more acidic. Now, if the solution is becoming more acidic, it means that there must be more H plus ions going into solution. So more H plus ions are going into solution. Now, if we look at the hydrogen electrode or the hydrogen reaction, you can see that hydrogen, when it oxidizes, will form H plus. So when we write it this way, when it oxidizes, it's going to give me the H plus that's going to reduce the pH. Now, if H2 is being oxidized, it means that it must be happening at the anode, because remember, at the anode you have oxidation and at the cathode you have reduction. So PT is going to be our answer. Of course, there is a different way you could do it. You could use the EMF route. You could say, okay, the EMF is 0.34. So you can say EMF is going to equal E of the cathode minus E of the anode. Now, the only way that we can get 0.34 is if we use Cu. There's Cu here, let me highlight it. So this one and the hydrogen. Now, to get a positive 0.34, I need to have the copper at the cathode and I need to have the hydrogen at the anode. So that must then mean, by process of elimination, if the hydrogen is at the anode, it means that the answer is going to be PT. So this is going to be the copper and this is going to be the H2. There's two ways you could do it, either one, doesn't really matter. Now, question 8.2. Does the mass of platinum increase, decrease, or remain the same? It remains the same. The reason why it remains the same is because if you consider the hydrogen, H2 is a gas. And when it oxidizes, it's forming H plus, which is aqueous, it's in solution. Now, for the reaction to occur, there must be a surface for this thing to occur on. Now, you need to choose a surface that is unreactive. Platinum is such an example. Question 8.3.1. Write down the half reaction to support the answer in 8.2.1. We are showing hydrogen oxidizing. So H2 going to 2H plus 2 electrons. Question 8.3.2. Write down the initial temperature. If it's at standard conditions, it means that the temperature is 25 degrees Celsius. 8.3.3. The initial concentration, if it's at standard conditions, it's 1 mole per dm cubed. Question 8.4. Refer to the table of standard reduction potential and write down the formula of the cations in the cathode. So we've already answered that. We said if the EMF is 0.34, then it must be copper. So they want to know what is the cation that is forming, or the cation involved is going to be the Cu2 plus. So Cu2 plus. Question 8.5, hence write down the cell notation for the cell. So cell notation, we write at the anode first, then the cathode. At the anode, I have PT, which is a solid. And for cell notation, you use a vertical line to represent different phases. So PT is a solid, and I'm going to use a vertical line to separate the PT. Then I have hydrogen, H2, which is being oxidized to H+. So again, I'm using a vertical line because H2 is a gas and H+ is aqueous. Then I'm going to have my salt bridge, so double vertical line. And then I'm going to have the Cu2+ vertical line going to Cu. In case you haven't realized this yet, since the H2 is being oxidized, the copper is going to be reduced. The one that's above, when we're dealing with a galvanic cell, the one that's above, it will be written from right to left, and the one that's below will be written from left to right. Question 8.6. The hydrogen half cell is replaced with another half cell that undergoes oxidation. Okay, so just like the hydrogen. The initial EMF of the cell under standard conditions changes to 0.75. Fully explain if the platinum electrode is still required. Choose yes from no, or choose yes or no, and support the answer with a relevant calculation. So, in other words, this hydrogen is gone. But they tell us that whatever the cell is, it's going to be oxidized. So that gives us a clue that the cell that we're looking for is going to be above the green one. Right? So let us clear this out. Now we can figure that out by doing the EMF calculation. We can say EMF is going to equal E of the cathode minus E of the anode. So EMF, they tell us, is 0.75. The cathode is 0.34 minus the anode. We don't know what it is, so let's just put X. Now we can solve for X. X is going to equal minus 0.41. So we look for that, and it's going to be right here. It's this chromium one, right? And so that's going to be oxidized, so it's going to be chromium 2 plus going to chromium 3 plus. But the question is the platinum still required? The answer is yes. The platinum is still required. Why will the platinum still be required? It's going to be required because Cr2 plus is an ion. It's aqueous solution. The Cr3 plus is also an ion. It's also an aqueous solution. There is no solid surface to react on. So no solid surface to react. And that's why we need the platinum. Now let's move on. This was the last question in the paper, I believe. Question number 9. Two different cells, A and B, are shown in the diagram below. Cell A contains concentrated solution of sodium chloride, and cell B contains a concentrated solution of copper 2 chloride. P, Q, R, and S are identical carbon electrodes. Chlorine gas is formed at electrode P and S. So at P, I have chlorine gas, and at S, I have chlorine gas. So 9.1, are the above cells galvanic or electrolytic? They are obviously going to be electrolytic. Why? Because the last question in the paper. But the more correct answer is there's a power source. There is a power source present. Question 9.2, we'll leave that out. Question 9.3, write down the equation for the half reaction taking place at electrode Q. Now we've got to be careful because at electrode Q, let me just draw this out for us. We have two electrodes, right? But don't be mistaken to think, or in thinking, that there's only Na and Cl in here. We have Na plus ions, we have Cl minus ions, and we also have, remember, it is a concentrated solution. So there's also H2O there. Now, the chlorine has already been accounted for. The chlorine is going here to electrode P. So let me just move that. The chlorine is going there and it is forming chlorine gas. So we don't need to worry about that. We need to think about, is the water or the Na plus going to go to Q? So let's figure out first what happened to the chlorine. The chlorine ion went to Cl2. So where is that reaction? Let's look at our table. Chlorine, Cl minus, right here. There's the reaction. So we are writing this reaction from right to left. So the chlorine was oxidized. Right? The chlorine was oxidized. So we are looking for the one that's going to be reduced between H2O and Na+. Let's find those. So we have H2O and Na+. Here's Na and here's H2O. Now, the one that's going to be reduced is the one that's going to be the better oxidizing agent, or in more simple terms, the one that's lower down. Remember, as you go down, you are increasing the oxidizing ability, or in other words, you're going to want to be reduced. Water is actually lower down than the Na, so the water is going to be reduced here. So the reduction half reaction, I write from left to right. It's going to be H2O or 2H2O plus 2 electrons going to H2 plus 2OH minus. And that's my answer. This is the answer here. Question 9.4. Write down the name or symbol of the product formed at electrode R. Okay, so if I look at that cell, I have Cu2 plus, I have Cl minus. They then tell me that it's concentrated as well, so there's probably going to be water. Now I have these two cells. At S, the chlorine is going to travel there. So chlorine is going to go there. So what is happening to the chlorine? Well, again, the chlorine is being oxidized. So Cl minus going to Cl2, and it's going to be plus 2 electrons. Now, between the copper 2 plus and the H2O, which one is going to be reduced? So let's find the copper 2 plus reaction. Copper 2 plus. Here we go. Copper solid and copper 2 plus. The copper is clearly more down, right? So copper is going to be reduced. I'm going to write it from left to right. So the thing that is forming is going to be Cu. So the answer to this question is Cu. Question 9.5. What happens to the concentration of the electrolyte in cell B? So here, when the cell is in operation, write down increases, decreases, or remain the same. Give a reason for the answer. So you can think of it like this. If I have Cu2 plus, and the Cu2 plus is going to be reduced and form copper solid on the electrode, I'm going to have fewer and fewer Cu2 plus ions in solution because they are coming out of solution. That means the concentration is going to decrease, and that's because the Cu2 plus is being reduced. It is coming out of solution, and forming Cu solid. And that's it. Thanks so much for watching. Don't forget to like, share, and subscribe. We are on our way to 500 subscribers. I'll see you in the next one. Bye-bye.